Alright, so hopefully we are live. So hello and welcome. We're going to take a look at another problem, and we just spent 7.5 hours looking at one problem, so hopefully hopefully we get do this one a little bit quicker. We'll see how this goes. Give this one a shot as well. Alright, the problem is going to be reconstruct original digits from English. Just give me just one moment. Yeah, here we are. Okay. Given a string S containing an out-of-order English representation of digits 0 through 9, return the digits in ascending order. Given a string S containing an out-of-order English representation of digits 0 through 9, return the digits in ascending order. 0, 1, 2. Oh, wow. So 0, 1, and 2. Oh, that's interesting. 5 and 4, 4, 5. 10 to the 5th. Whoa. So 10 to the 5th characters. SBI is one of the characters. One of these characters. S is guaranteed to be valid. That's super interesting. I mean, this is pretty easy, I think. So I'll just tell you. I'll just code it and then explain it. So we're going to use a frequency map. Yeah, we'll do. It's going to be int. Actually, you don't even need that. We're going to say 26, 0 for auto. Frequency of C minus A plus. And so we build a frequency map, and then we're going to say 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So we're going to just write a quick build frequency. Quick routine here. See how quickly we can do this. And we're going to say something like this. Actually, this could be more challenging than I realize. We'll see how this goes. We'll see how this goes. So excuse me. Digits. Digits in English. Using an initialization list. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. People made a lot of downvotes for this, huh? 2, 3, 4, 5, 6, 7, 8, 9. 1, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Good. And now we just say for auto frequency maps are going to be this build frequency of the string S. There we go. Yeah. So build over frequency maps. Build a frequency map for each digit in English. Build a frequency map of the input string. Remove, given that the input t be valid, can remove digits until our frequency map is empty. Now here's the question that we have. Here's the question that we have. There may be multiple possible choices, I suppose, of a I'm wondering if it's easier to just curious. The tricky thing here, I think, is so we spent a good 8 minutes already doing this, setting this up. This could be wrong now I'm thinking about it. Part of the issue here, I think, is if we just remove any digit that is possible to remove, like I want to say that there's sort of a frequency of digits that we have. We're going to build yet another frequency map, but the issue is, like, you could have overlapping characters, which you do. You have definitely the vowels overlap, right? There's an E and a one E and one O in 0, but there's also one E and one O in 1, and there's an O in 2, and there are 2 E's in 3. Right, so there's a bit of overlap over each I guess word. However, I guess what I want to say is that, like, for instance, could you have, well, 0, there's got to be a 1Z, and N I don't think overlaps. N overlaps at 7, but there's a V for 7, right? I want to say something like you could maybe take something out for a 1 that was meant for a 7, right? Something like that. If you could identify unique characters for each, then I think you're in good shape. So I don't know how many N's there are. There's an N for 1 and N for 7. So 1 is not really unique. So I guess you would do 1 last. And 2, the W, I think is unique to 2. So 0 is unique. 2 could be, yeah, you could identify 0 uniquely. You could identify 2 uniquely. You can identify, the H is not unique. T is not unique either, right? 8, yeah, H and T, TH. So 3 is, the R might, no, R is not unique for 3. Or R is not, 3 is not unique. 4 is not unique. 5 is almost, except 7 also shares a V. So 5 isn't really unique either. 5 east. Actually, this might be a little bit harder than I thought. Hopefully not. Yeah, F is not unique. I is certainly not unique. V is not unique. E is not, has nothing unique there. 6 is not unique either, right? Oh, the X might be unique for 6. 7 is not really unique either. None of those characters are unique to 7. 8 is none of those characters are unique to 8. G, actually G might be unique to 8. Yeah, G is unique to 8. 9, let me actually... just... So we say yes, no, yes, the W, no, 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 yes, the X is, 7 is not, no, yes, the G is, and 9 is no. The N, yeah, the N and the I and the E. So you could remove the 8s, the 6s, the 2s, and the 0s, but you still have 1, 3, 4, 5, 7, and 9. Some combination of these values, I guess, represents your frequency map. And that's the tricky thing, is we want to know how many. And you could use a what do they call that? There's a few things you could do. So, and it's 100,000 characters, so it's quite a few. So, okay, you can use a backtracking algorithm to remove each frequency, and then if you run into a problem, then you can back up. But it doesn't actually matter the order that you remove these. So actually you can do something better than that. Instead of just a backtracking, you can do I want to say you can use some dynamic programming. So the frequency map changes if you choose 1, 0. In other words, you could pick one of these 9 choices, these 10. You could pick one of these 10 choices, and if any of the results from those 10 choices, I guess you would recurse, right, on those 10 choices. If any of those are still valid, given those frequency maps, then that's sort of the choice you would make, right? Whichever one of those is valid. You'd return that one. So really you'd have a pair, I guess. You'd return if it's true or false, it's valid or not, and then you'd return a frequency map of the digits, which is just another vector. So you could do this recursively too. That would be dynamic programming. Where I'm wondering if you could flip that dynamic programming over, but yeah, you would memoize. Now the problem with that, see, that recursion, like, that could work, but you can't really memoize that because the frequency map is different at each point. Yeah. Actually, is effectively the dynamic that problem that approach is very similar, if not the same thing, as the backtracking solution. Just picking any of the 10 possibilities and kind of going from there. So this is a little more difficult than I was expecting. We'll say that. This is a little more difficult than I was expecting. Got a lot of downvotes. Maybe that's why. It's a challenging question. It's a challenging question. A little more challenging than I was expecting. 100,000 characters is like kind of brutal. Yeah, it's got to be done in basically linear time. Yeah, the real crux of the problem, I think, is not confusing from the outset the characters that are meant for, I guess, one set of characters and not meant for another. Like you could have 4, 5, 7, and what did we say? So there's 1, 3, 4, 5, and 7, and 9. You could have like a variety of these such that it's not clear. I want to say there's a combination of digits that you could do, where you could pick a 9, I guess, when actually 9 with respect to these other, 9 when that I was really for a 5 and these two N's were for 2 1s. And so what can happen is you would have 2 1s, a 5. Actually, that's all you need. 2 1s and a 5. If you take a 9 out instead of a 1 or a 5, then you won't be able to complete anything else, and so you have to back up. So you can't just take whatever you want, right? That's kind of why I was saying if they were independent, then you could grab whatever you wanted, any sequence, any order, any possibilities. So that's kind of tricky. That's good example is a 1 1 and a 5. You could try to take a 9 out there, and you'd be left with you wouldn't have the characters to build that really much else after you take the 9. And so that would be just the wrong answer if you try to start with 9. It's a lot of different guesses, though. It's not very efficient. That's the problem. With 100,000 characters, trying to run an algorithm like that, I think, would be extremely inefficient. Wow. Uh-oh. I don't think we're solving this quickly. I don't think so. I have to lay down and think about it some more. Nope. We got stopped in our tracks here. Stopped in our tracks. Yeah, because what I was hoping for was I could just kind of grab the a well, maybe I'm wondering if you can do 1 digit at a time and you find as many of that digit as you can. Is that an approach that could work? So you find as many digits as you can, one digit at a time. I guess what I want to say is, like, you could maybe do a kind of like a binary search where you could try to determine how many digits there should be for each digit. It's not necessarily the maximum number of these digits, but it's a tricky thing, because if you just grab, if you start with 9 and you say, okay, you can grab 1 9, but then you can't make any other digits from what's left over, then obviously that's too many 9s. So you have to put at least 1 back. It's that kind of approach. That's a kind of backtracking approach, but I don't know if that's the right way to do it, if there's a better way. Just thinking here. There are a lot of different paths that'll lead to the right answer, so you don't necessarily want to. So you probably do want to go with like a depth first search rather than a breadth first search. You definitely don't want to go through all of the possibilities. You want like a terminate early kind of a thing. But I think part of the issue is trying to figure out, like, for instance, how many 1s there might be. It could be, excuse me, it could be a lot of different ones you could mark as one, a lot of different, yeah, you could mark down a lot of 1s, but those might be using characters from other words. Yeah, the other words that might be supposed to be used that character, and you don't know how many you're actually supposed to have the 1 of 1. That's tricky. I don't know. I don't know how I would solve this. I don't know. Yeah, just the frequency map is kind of challenging. I'm kind of biased now because I already coded it, but I think actually just a frequency map is maybe not the best idea. Somewhat pondering, like, what if you sorted the characters? I don't know if that really helps very much. Excuse me. I feel like you'd be kind of just looking at like another form of frequency map where all of your characters are just plopped into sections. Excuse me. So interesting question. Excuse me. I'm wondering if there's a path that we can always take that would eliminate. You might be able to do it that way, actually. Basically, take a look at which of these sequences share digits with others. Oh, I think that's how you do it. Oh yeah, okay, that might be it. That's probably it. Basically, you figure out which sequences. You basically define a sequence on like which characters you take away from the frequency map first, and take it as many as you can, and then go to the next one and do it that way. And the reason you do it this way, I think, is because you can. I think I got it. I think I know what to do. You can basically know that you aren't you don't have any sort of unique characters anymore. So let me explain. So like 1 has O, N, and E, and so the other things, if you've already found all of them, then you can find all of the 1s, right? So everything with an O is 0, 2, 4, and that's it. Right? So you found all your 0s, 2s, and 4s, and you can go for all of your 1s. Well, not quite, but that's for all of the O's. 0, 1, 2, 4. Then N's, you have 7, and 9. And then E, you have also 0 again, 3, and 5, 7 again, 8, oops. I guess we'll just make them like a kind of a, I don't know. Yeah, there's only 2 things with the N's, 9 and 7. And then we said 0, 3, E, right? 0, 3, 5, 7 again, 8 and 9. So that's 0, 0, 2, 3, 4, 5. The only one that's not here is 6. Yeah. So 1 might be like the last thing that we do. So that would be gather everything up. 0, 2, 3, 4, 5, 7, 8, and 9. Literally the only one that you would do before 1 would be 6. Two. We said 0 could be identified uniquely by the Z. 2 can also be identified uniquely by W. 3, we want to wait till we have all of, and obviously we can kind of cross out the ones that could be uniquely identified, which is 0 and 2. So those we could take those out immediately. 6 and 8 also. Okay. And then 3, you have, we don't even need to count 0, 2. We can do, we don't have 1, we have, no, do we have 1? Oh, we do have 1, yeah. 3 and 1, 1 and 3, right? Because I'm not sure if what I'm suggesting actually makes any sense, because they're mutual with each other, right? So, well, I guess you can kind of narrow it down to like, well, they don't not all of their characters overlap with each other. So there might be one character that's present in 3 or 1 that's not present in the other. Huh. I'm not really sure. Certainly there's no N's. It's like if it was just between 3 or 1, you could figure that out, right? If there's an N. So I think that's kind of the issue, is that we kind of want to figure out like what the next choice is going to be. So something like that. I'm not really sure. I don't know. We'll just kind of take a little more information and see what we come up with. So 3, you could have a 1. Let's not even consider the ones that have the yeses already, where they're uniquely defined by a single character, because those will already be kind of taken out. So 3, 1, 4 doesn't have an E. 5, 7 has E's, and 9 has an E as well. 4 has 1, shares an O, 3 shares an R. Right, I missed that actually. 4 does share an R with E with 3. 4 shares an O with 1, an R with 3, an F with 5, and it doesn't share anything with 7, and it doesn't share anything with 9 either. Okay, so 4 is looking like a good candidate for the next one. This is 1, 2, 3, 4, 5, 6. So 1, 3, 4, 5. Same thing, we should have 4 in there. So shares an E with a 1, shares an E with a 3, shares an F with a 4. So 1, we have 3, we have 4, we have an E with 7, and an I with and an E with 9. Okay. 1, 3, 4, 5, 7. Similarly, 1 with an E, 3 with an E, 4, not 4, 5 with an E, and 9 with an N. Finally, 9. One E with a 3, 1 is an E and an N. 4, we don't share a 4 with 9. I with 5, 7, and I think that's it. 1, 3, not a 4, 5, 7. It's only 6 of these, right? Yeah, okay. So that's interesting. So probably you would want 1, 2, 3, 4, 5. So 1 is like shared among everything. So is 3. But 4 might be one of the kind of like first ones you potentially start with. So can you identify 4 uniquely among 1, 3, and 5, right? So there's the F, the U for 4. Oh yeah, no, nothing says shares a U with 4, right? Oh, I missed that. Whoops. That is unique. I'm sorry. 4 you don't need to worry about at all. Take that back. Okay, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Yeah. So right. Okay, you uniquely identify 4 as well. I missed that. In that case, 5. Okay, so is there a character in this set that's unique to 5 with respect to the other characters? See, that's the key. So now, the sequence you'd want to do is you can do 0, 2. You can do 0, 2, 4, 6, and 8 in any order you want. And now you want to do, once you've done that, you want to do 5, because you can identify F on 5. Oops. Just use, yeah. You can identify F on 5, and then that would take care of 5 for everybody else, right? Because there's only, the F is the only character, there's no Fs in the other ones, right? then what? If there's an O in 1, which makes you don't need, or rather, yeah, there's an O in 1, so you don't need to worry about 1 for the others either. Obviously 5 we already did. So the number of O's is going to tell you how many 1s you're going to do. So you do 1 next. So these characters are just free for all the characters. Like, this doesn't matter. 0. Actually, no. Sorry, they're not all the characters. They're uniquely identified, right? So 0 is Z. 2 is W. 4 is O, or no, U. Excuse me, U. 6 is X. These characters are only present in these particular numbers. G is H. Is 8. Or G, yeah, G is 8. 5 is then F. Shared amongst 4, but 4 is already gone. 1. So this is kind of a process elimination kind of deal you can do. This is a pretty interesting question. I like this. It's kind of a really challenging question. I think for an interview, I'd like really be frustrated with this. But 1 is O, and now 2. Oh, we already did 2, but yeah. So 1 is now eliminated. Now you have 3, 7, and 9 to look through. I think T is unique now between these guys, right? So T doesn't exist for what's left for 7 and 9. So you do T for 3. And then you have between 7 and 9, S is not in, or V. You could do either one. You could do V. Whatever V's are left over is for 7s. And then finally, 9 is, I guess it's just your E's, let's say. Number of E's. And basically that's how many, in that order, that's the order you want to go through, and that's the order you want to go through, and that's also how many of each of these characters is how many of those particular digits are going to have. So we can create this, we can encode this pair as well. We do a vector of pairs. Can remove characters. Note, there is special encoding the sequence of characters. The processing sequence. So we'll just say standard vector it's going to be an int to a character. Coding sequence or processing sequence. And that's going to look like the following. And there's 10 of these. You just go in that order. Pretty interesting question. I like this question. I feel like a genius figuring this out. The int, so we have pair, vector, yeah, so we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Get that right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah. And we look at our notes. Oops. Our notes, it's 0 to Z. W, 2 to W. 4 to U. Oops. 6 to X. 8 to G, 5 to F, 1 to O, 3 to T, 7 to V, and 9 to E. There we go. So we're going to say for this processing sequence, we're going to say for pretty much auto P in processing sequence. We're going to say int val equals P dot first, character, which character, our target character equals P dot second. We're going to say, we have also ret, or a vector of integers. It's going to be 26. Oh no, there's only 10 digits. 10 digits, and they start off at 0. We're going to say ret of, so ret of value plus equals the frequency of the target character minus, so that's how many characters are in the frequency map, that's how many we're going to remove, right? So we'll say int total, or total in frequency map, or total in frequency, total remaining is equal to this amount, total remaining. And then we're going to say for each character in, so digits in English, say remove each character or take the frequency map difference. Once by removing all of the character. Yeah, I guess we'll just take the frequency map difference. It's kind of complicated to explain exactly what this does, but basically we're going to say for each value, each digit in this frequency map. So frequency maps, so for int I equals 0, I is less than 26, plus I, we're going to say total remaining times frequency maps of, say, const auto current map. It's going to be frequency maps of this particular digit in English, right? So val, so target character, which digit, say. So this which digit, now this is a current map, right? And we're going to say, we're going to take our frequency map and subtract all of these, each of these for each character. So total remaining times this current map of, actually it's just going to be I each time. Right, so the current map will be 0 everywhere except for spots where the digit exists, or 1 or 2 digits exist, or more than 1 digit, at least 1 digit exists. So you have the total remaining times those digits, subtract from that current map from the frequency, or input frequency. We could change this to input frequency. So that way it's a little more clear what this is, because now we have a whole bunch of different frequency maps that we're working with. Yeah, so this target character, we count how many, and then now we're going to remove, so we add in our ret value, total remaining, right? And then we take the frequency map difference by removing each character in the digit frequency map from the input frequency map, right? And we speed this up by just multiplying by the total remaining. Okay, so that's for each of these values in the processing sequence. We do that. And at the end of it, this frequency map should be empty. Ret should be available. Now we can take ret and say we're going to build a string. So could do something like standard result string, and we can say, could also do a string stream, I think. Might be, I'm not sure if it's easier to use a string stream or or just a regular string. Call it result. We're going to say for int I equals 0, I is less than 10, plus I. We're going to say for j equals 0, j is less than ret of I plus j. And we're going to say result. We're going to input a I, actually, and then return result.string. Something like this. Does that compile? No. It's stream, it's not a string stream. Fatal error, file not found. Utility, not pair. Or it is string stream. Maybe I'm crazy. Oh. No, it's stream, but I typed include incorrectly. Line 52. Oh, yeah, there's that too. Forgot about that. Ret, which digit? Forgot that too. Frequency of I. Input frequency. Changed all my I kept changing my variable names. Oh, there we go. 0 milliseconds, and it's correct. Sweet. Sweet. Now the thing that's tricky about this is all the different test cases we might want to use. Okay, there's at least one character, right? So if we could do like N-E-O, E-N-O, this should be an invalid test case, I think the fourth one. How did we do? Oh, we're at 50 minutes? Oh, no, I thought I was doing so well too. Yeah, 50 minutes is kind of a lot. I think we're at, yeah, I think we got it. The issue is just, so 0, 9, 5, 4, 4, 2, 9, 1, 2, 3, 4, 5, 6, 7, 8, 9, 1, 2, 0, 2, 1, 2, 3, 4, 5, 6, 7, 8, 9. Something like that. How does that look? Alright, I think we just go for it. Hey, you got there. Sweet. Not too shabby. Wow. Slower than everybody else. Okay, so it took almost an hour. Alright, 12 milliseconds is better. 6, no, man. I think 100% is like 0 milliseconds. Man. I thought it was so smart figuring this out too. Well, it took me forever to get there. I think if you hard code some of this stuff. I mean, you don't necessarily need these. I think you don't actually need to create these frequency maps here to do the calculation. I think that might be part of the slowdown, because you can do yeah, you don't need to go through the current map. You can just do if you do digits in English, you go digits in English of I, not I, of which digit. And you can say is input frequency character minus A minus equals total remaining times. Yeah, that's fine. Yeah. Actually, yeah, just that's it. I think that works too. About that. That's a little bit faster, or not much faster. Maybe it's faster. Might be faster. I don't know. Could be. Seems like it's faster that way. Do we need to build this frequency map? I don't think so. Do we even use this? I don't think we need that either. That probably is like a big chunk of processing time. It's just that. I'm gonna give this one an upvote. I like this one. This is a nice break from the other questions. You can also hard code this. And I have this loop through this processing sequence, but actually you could just actually do each one by one. Like unroll this loop, you know? Yeah, just unroll the loop. Get rid of this for loop. I'm tempted to do that because I want to get 100% before I go to bed. 12 is pretty good. Yeah. times. Man, I think I'm going to do it. I think I'm going to unroll this loop. The reason why you also want to unroll the loop is you don't need to create this either. You can even unroll this too. This loop, these loops. Well, that's kind of extreme. That's kind of extreme. You also don't need all this memory either. You don't need 26 characters here. You could do, well, it's probably better just do 26. It's probably better to do it that way. All right, let's unroll this loop. Let's see what this looks like. So we're actually going to take this whole thing, copy it. Well, yeah. Comment this out. Unroll it. So we get so we don't have a sequence anymore. Which digit, which character will be, it's going to be 0, and then target character is going to be Z, and then total remaining is going to be input frequency as target character, ret of which digit, add that total remaining, and then we're going to unroll this loop. Yeah, loop unrolling is kind of interesting. Usually loop unrolling, you just kind of like, it's almost like you just take chunks of the loop out instead of, I mean, we're taking the entire loop out, but you might do like half of the loop or something. So you would do like 2 or 3 of these iterations, and then, you know, a third of the loop you would do something like that. Like loop unrolling is not usually the entire loop that you take out, but sometimes you do. In this case we can, so we will. So now we're going to set our which digit to the next one, which is 2. This is crazy. This is crazy. It's 2 and W. 2, W. We don't need all this here. Code is pretty much the same each time. And it's 4 and X, or 4 and U. And it's 6 and X. We got 4 and U. We got 6 and X. We got 8 and G. Excuse me, 5 and F. One and O. Three and T. 7 and V. Hopefully did this correctly. And finally 9 and E. This would be a lot harder if this wasn't, you weren't able to kind of get this order correct, I guess. this processing sequence. Oh no, I put the, oh, shoot, made a mistake. Whoops. Got to get rid of this. Now every mistake that I made, I have to, it's going to be there 9 times, 10 times. It's good. It's fun. That's pretty funny. Don't mind me, just lots of typing. Lots of typing. Try that again. Oh no. Well, but. It's always good. Lots and lots of mundane and rote and manual things. There we go. See if it's right. Okay. We'll know the unrolled the loop. Did we save very much in efficiency? I don't think so. I don't know if it's really all that much more efficient anyway. Still 24 milliseconds. Oh boy. We're trying to get to like under 12. Did we get under 12? We got 12 once. If we can get like 8 or 4, that's what we're going for. Got 16 a few times. Man. Alright, we got 12 again. Let's see if we can get better than 12. I don't know. I think we'd have to do one more trick to get it faster. Also, I need to go to sleep. 1, 2, 3. You need to do each of these unrolled as well. So you unroll each of these as well too. Oh no, oh man. Yeah, you could do that. Oh wow. Okay. That seems like a lot of work. Do character by character. This is 4 of these. Yeah, you could unroll each of these loops if you wanted to. Although again, it's like, is that really? What does that do for you? Interesting. 0. 1. Yeah, no kidding. It's too funny. No, 0 should be, oh no, this should be 4. This is astounding. It's ridiculous. What am I doing? 2, I guess not too bad. It's a little ridiculous. Yeah, it's a little ridiculous. 4, 6. 8. 8, 5. 1. 3. 7. 7. Oh man, that's a lot. Wee. And then 9. Okay. Oh boy. Alright, what does that look like? Still looks like it might be right. Not much faster though. Really not much faster. But we don't need this anymore, do we? Oh boy. It's great. This is great. Okay. 36 milliseconds. 28. 20. 20. Trying to get down to 8 milliseconds. 12. We got to 12. Alright. 12 again. No. Even unrolling these loops, man. Even unrolling these loops. I guess the question is, do I need to do all of these subtractions? That's kind of the next question. Like, you probably don't need this part on the last number, certainly, right? I don't think the last number matters anymore. The last digit. Just can't get quite get to 8 milliseconds. I think these are it's crazy. I guess those last parts become somewhat unnecessary. I think this gets optimized out anyway, this which digit and this total remaining and this target character. I think all that gets optimized out. In fact, we don't even need to remove the ends over here either. We can just do, the last thing we care about is the E. So we really only need to do this twice. So we remove even more. Could do even another slight optimization is you do E total remaining bit shifted to the left 1. So you multiply, that's multiplying by 2. only need to remove 2 E's, right, because those are the only things that matter to 9 are the E's at the end there. And then you could say the A's also. You need to remove the, for 3, there's no A's to remove. So only care about the E's here. T, H, and R. Yeah, only care about the E's for 9 and the V's for 7. So again, so E could be the same thing. Same optimization for E, I think. Whew. Let's see, you have E's for 1, but O's we don't care about at all for any of these. So E we care about, V, there's no V, so again only E we care about for these two. Can get rid of those as well, which is interesting. I think that's true. Yeah, so slight optimizations here and there after we've unrolled this loop. O's, 5 doesn't have any O's. V's we care about, I's and F's we don't care about. I don't think so. We do care about the V's though, interestingly enough, and the E's. Got a couple more lines. It's definitely, it's like not that much more efficient, but I think we shaved off a few milliseconds overall, right? Like getting closer. Definitely getting closer. Or at least I think we're getting closer. I don't know. I need to go to bed. I'm trying to get that 100%, man. Spent like 15 minutes already on this. Could have solved another problem. Okay, how about we have F's. E's, I's we don't care about after that point. G's we don't care about at all. H's, nobody cares about H. T's we don't care about either, I think, right? Is that still correct? Oh, it's wrong. Ooh. F. O, T. Oh, we do care about T's. Take that back. The 3 is T's. V and E. Alright, let's try that. I think that's still right. Just got 3 more lines. We're like slowly shaving down the code, and as it, you know, it's probably likely that like this isn't even like the majority of the code. It's probably such a minor portion. It's probably the largest part of the code is, excuse me, the stream and the input frequency in the first place. Like I'm just wasting time with this part. This just doesn't matter at all. Could probably unroll this loop too and just add total remaining on each one. Yeah, you could probably remove all of these lines and just add straight to the return value. Add that character that many times. I want to say you can do, actually, you could try this, I guess. No, actually, you do want to do it in order. Take it back, yeah, because this isn't really in order. You kind of unroll the order, or you kind of revert the order at the end. So you would do, you could do something like this though. We're gonna say red of I, and the character is gonna be I. How about that? Something like this. Is that even correct as I compile? Looks correct. Okay, is that faster? It might be faster. Maybe. Oh, we're so close. 8 milliseconds. Yeah, so that was a big deal. That string manipulation right there. Oh man. Getting closer, man. Getting closer. Can't believe we hit that 8 millisecond mark. Yeah, string manipulation is expensive. 1, 2, 3. One, two, three. We're so close. We're so close. So it's not even this stuff that's taking so much time. It's the string manipulation. The question is, do we even need this input frequency? Is that even that important? Yeah, I mean, I think this is fine. We're so close. I guess 4 milliseconds must be the fastest then. Ridiculously close. I wonder if this just being a string matters. Get the feeling like it doesn't, or get the feeling it's actually faster to the string stream. How about that? What does that do? Is that any faster? Seems like that's probably just a little bit slower. Yeah, it's a little slower. The string stream's a little bit faster. It's kind of interesting if that's the case. Oh no, still get 8 milliseconds. I don't know, man. I think the string stream's faster. Because before we were at like 12 and 8 milliseconds pretty consistently. I think we had it right the first time. Yeah, it's definitely faster. Now the question is, can we make this even faster? What could we possibly do to make this faster? I want to say we could remove more of these unnecessary lines. Don't think it improves it that much though. I think the big improvement would come from this. Do we need this though? Yeah, we kind of need this. Oh man, that's so close. I really need to go to sleep. Almost an hour and a half. Okay. Alright, we'll try to do one more. So 6. S and I maybe. I don't care about the I. definitely, we might care about the, I don't think we care about the S either. Yeah, I'm not sure that matters at all. Oh, we did it! Yes! Ah, we got 100%. Yes! I knew it. I knew we could do it. It's actually a little bit more optimization to go to. I think we can get rid of the R and the U, maybe the O and the F. Probably the F we have to leave. But I think the O, the U, and the R, we can also get rid of those. It's pretty funny. That's great. I think so. Let's try that. Oh no. Oh wow. Oops. What happened? Wait. Yeah, the U we don't need. The R I don't think we care about. Yeah. Maybe we need the O though. What's up with the O? Is there an O somewhere here? Oh yeah, there is an O. Yeah, yeah. So we actually remove U and R too. I think there's an F down the line as well. Yeah. Wow, amazing. So we got that 4. I don't know if we can get it again. It's pretty funny. Just randomly got 100%. Not bad. So maybe anything else we could remove? We definitely don't need W. Is there a T and an O? There's definitely an O. Is there a T? I think there's a T. Yeah. I don't think we care about Z. Definitely don't need Z. What about E? Yeah, there's probably an E somewhere. Got E at the end, yeah. What about R? Is there an R anywhere? I don't think so. I think this R is used anywhere. Interesting. The E and the O is used though quite a bit. So we moved. We removed lines of code. We did that. We got to 4 milliseconds just randomly. We're getting so close. We're so close. Got 8 milliseconds a few times. 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. I think I want to say there's even another approach we could take to optimizing here, which is interesting and fun, which would be instead of using these vowels for any of the like determining these digits and these target characters, because you can kind of use whatever target character you want. I guess instead of using the vowels, you could use like N here and then divide by 2 for this total remaining, and then you don't need to look for E for these parts, so then you can get rid of this E here. We do need this N. So you like sort of save an operation there, I guess. Then you don't need to look for the E's over here, right? In fact, you don't need even the N or the E here. And then over here, you would need this N though. So you have to return the N there. But you would need this E, right? So switching that E to an N would be better. So we changed the vowels that we're looking for to consonants that are less frequent. That would actually optimize this slightly as well. But it's sort of minuscule optimization that it's like also not to mention we mostly optimized this anyway. I think I don't think any of these necessarily need to use E. It's only the 9 at the end. There's an I in 6. You could use I instead of N. Oh, there's an I in. There's a few I's. Yeah. 6, 5. I think N might be better. Well, a few things have N too. Like 1 has N. Really interesting. I don't know if there's really any other more optimizations I could think of. I think we got the 4, which is pretty good. 4 milliseconds, but we're not quite. We're so close. We're not like consistently hitting 4. We hit it like once. Oh, 8 milliseconds. Oh, that's so close. Yeah, we got it one time. Alright, we'll go for like a couple more rolls. So close. So close. Yeah, I don't know, man. I don't like not getting 100%. It's annoying. It's frustrating. It's like, I waste so much time doing this though. It's already an hour and a half. This is probably wrong for me to keep doing this. Let me do like a couple more rolls, like 2 more rolls. 1, 2. Let's do 4 more. 1, 2, 3, 4. Let's do 4 more. 1, 2, 3, 4. It's so close. Maybe 4 more. Maybe just 1, 2, 3, 4. Alright. Okay. I don't know what else we could do. I guess changing to N on the end here, we could try that. See if that makes a difference. Do N divided by 2. Bit shift to the right. And then actually I'll do it this way. Right, and then so now we don't need to keep track of E, but we do need to keep track of N. Don't need to keep track of E anymore. Anywhere you see an N though, you do need to have that. Excuse me, get rid of this E. Excuse me. One of these uses an O, is that right? Oh yeah. One uses an O. Oh, okay, makes sense. It's kind of a rough one. Could get rid of this E. I don't think any of them use E at that point. It's like hardly faster at all. So maybe just a little bit faster. Maybe. Just means the odds of rolling a 4 is just slightly higher. I think the speed slowdown is like from the frequency map and the string stream. I really can't think of a faster way to do this. I don't have one. That's all I got. That's all I got. Apparently there's a way to do it with less memory. It's faster. Maybe that's what I'm missing here. Maybe there's a way to do it that doesn't involve as much memory usage. Ah, we're so close to getting 100%. We are so close. Somehow we use more memory though, I don't know. I guess we only need, you know what we can do? Oh, we do have Z, yeah. Okay, never mind. Where's all this memory usage coming from? We're so close. So close. We could probably pick different values, letters, to make it just slightly faster. Oh man, look at this. Oh, we're so close. We're so close. I don't know what happened where we just randomly hit 4 milliseconds before. Alright, we gotta go to bed. We gotta stop. This is like, it's terrible. I can't handle it, dude, when I'm like just a fraction of just a few milliseconds off. It's so frustrating. Not frustrating, but it's just like, I gotta get it. I gotta get it. Oh man. Divide array and increasing sequences. Alright, I think I could roll it like a few more times. Did it like 100 more times than I said I was gonna do. I gotta sleep. Oh, look, we got 28 now. Okay. It's definitely has something to do with like we really only need to keep track of a certain number of characters. We don't need to keep track of all 26. Looks like Z, W, U, X, G, F, O, T, and V, V and N. Excuse me. Only really 10 characters. Thing about it though is even if it's only 10 characters, I think using an unordered map for 10 characters is kind of poor. It's kind of bad. I think like adding a switch statement here would be kind of meaningless. For those 10 characters, so you could do like a switch statement for the 10 characters here, but I don't think that would really be all that meaningful or that good. We're so close. It's so tempting to just try some little optimization here if I could. I'm so tempted to try that next. I'm gonna do it. I'm gonna try it next. Use a switch statement inside here for the 10 characters that are relevant. Does that compile? Okay. So Z, W, F, Z, W, Z, W, U, X, G, U, X, G, F, O, T. V, N. Okay. Okay. What does this look like? Is that faster? Is that faster? Please don't tell me that's faster, because I would be like shocked if that's faster. Z, W, U, X. I mean, these all the hard coding to make things faster. T, V, and N. Alright, how about that? All kinds of hard coding. All kinds of hard coding. Is it actually faster? Probably not. Probably not by much, if it is. Oh man, it's too funny. 1, 2, 3. Cut me off, man. Say go to sleep. It's time for bed. Let's try again in a few seconds. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. They're like, this is excessive. You've been cut off. No more. No more. Submitted like 1,000. Oh, okay. They've had enough of me, man. They've had enough of me. I've been cut off. Have you ever been kicked off of a website before? For trying to use it too much? I got limited. I got rate limited. That's hysterical. Like, you're done. You're done for the day. It's time to go to bed. You're making our servers cry over here. Oh, that's too funny. Maybe can I go to a different problem and try to submit something? Oh, that's so funny. Hopefully they don't have my solution. Okay. Oh no. Alright. That's so funny. Like, nope, we did it too many times. Alright, well, we did get the 4 milliseconds at some point. I don't know, I guess I'll have to come back to this another time. That's too funny. Oh boy, that's great. Alright, let me save this. That's hysterical. I feel like I got kicked out. This is like what it feels like to get kicked out of an arcade. Just so you're having too much fun here. That's great. Oh man, that's funny. I can't believe that happened. I can't believe I got limited. I wonder if I can come back to this tomorrow, try it out, see if I'm still limited after a day. I got a lifetime I got a lifetime submission block for this problem. Like you can't do this anymore. Oh, that's so funny. Can I ever solve this problem again? No? Is that it? It's done? It's over? Oh boy. Alright, so I'm gonna go. Thank you all for watching. I'll talk to you soon. Oh man. That's hysterical. Maybe I can go to like an easy problem and see. Maybe go to an easy problem and see if I can submit one of the easy ones. Happy number. Oh, this is an easy? I thought this was a medium. Place the number by the sum of its square of its digits till the number equals 1. Loops endlessly in a cycle which does not include 1. Actually, that's kind of involved. I'm trying to look for like a really easy problem. One that I can just submit really quickly. Count primes. Just do like super easy. What's this say? Rotate digits, rotates. These are easy. These are actually kind of challenging, these ones. Flipping an image. Yeah, I remember these. These are not actually that easy. I'm looking like for a super easy one. Monotonic array. Sort array by parity. Reverse only letters. What does this one look like? A non-negative integer return rate considering all the even elements of nums followed by all the odd elements. Okay. Even elements followed by the odd elements. Interesting. Okay. You can actually do the sorting that we were doing before, right? So we'll do, we'll do int I equals, 0, j equals num size minus 1 for I is less than or equal to j. I'm going to say if I modulo 2 equals 0 and j, we're going to say a and b, right? Int a equals nums of I, b equals nums of j. So if a modulo 2 equals, actually you can even do modulo 2. So if a equals 0, b equals 0, else if a equals 0, b equals 1, else if a equals 1, b equals 0, and a equals 1, and b equals 1. Alrighty, so we'll say a is 0, b is 0. That means that a equals 0 means it's divisible by 2. We said we want even on the left side, so we would increment I here, and we would leave j where it is. And if a is 0, that means it's in the right spot. But b is odd, we can decrement j. In this case, here we would swap, I think. Nums of I, nums of j. Right, this is a is 1 was odd, and b is 0, which is even. So now I'll have an odd in this jth position, and then now if they're both even and odd, then the odd j position is in the right spot, so we'll leave it. So something like this should work. Let's go for it. See how we do. Ooh. No! I've been banned. I've been banned. No. No more submitting on Leetcode for today. Well, hopefully I could submit in the future and not just today that I've run into issues. That's what I wanted to try. I wanted to see if I could submit at all to their server. Oh man, what happened? All right, well, I'm gonna go. So I think I could clear my cookies. I could try clearing my cookies, and then I might be able to submit. Yeah, I'm tempted to try that. Tempted to do that. It's very tempting. Let's try it. Let's see. Let's see if this is by cookies or it might be by IP address. Hold on. Let me see. Let me see something here. Yeah, I think their server. It's probably by IP address. But I probably could clear a cookie also. I'm afraid to do that though. It kind of messes up my computer when I try to clear cookies. Let's see what we do. See what happens. I think it's gonna log me out. Also, uh-oh, I think we may have killed the stream. Oh man, let's see what happens here. Oh, is the stream still going? Let's see, are we still live? Hello. Hello, hello, hello. Okay, interesting. That's fun. Let's see. May have to log back into the website. I think so. Yeah, we do. Let's see what happens. Okay, so we're back in after we cleared everything. Let's see what happens now. All right, let's go for it. No. Oh man, I guess they blocked me. I don't know how long ago blocked me for. Huh. I know I'm gonna have to go read their guidelines. All right, well, I'm gonna go. Thank you all for watching. I'll talk to you soon. I don't know, man. I'm trying to get the 100%. All right.